Hi there. In the previous lessons, we have learned the definitions and observation principles of horizontal angles and vertical angles. We have gained a certain understanding of the formation of angles, and learned that angles like these can be observed using a theodolite. So, how should we place the theodolite before observation? Yes, there are 4 steps for placing a theodolite: centering, leveling, aiming, reading. Step 1. Centering. Previously, we mentioned that the horizontal angle is actually a spatial angle formed by projection in the horizontal plane. Therefore, in order to ensure the accuracy of angle observation, it is necessary to perform centering work. The purpose of centering is to make the center of instrument, vertical axis, and the survey station point, the vertex of angle, on the same vertical line. This is the basic requirement for measuring horizontal angles. Optical centering should be combined with instrument leveling. The steps for optical centering are as follows. 1. Fix the theodolite on a tripod. Adjust the focusing distance of ocular lens of optical centering device to obtain clear images of the circle mark of centering device and the survey station. 2. Rotate the foot screw of instrument so that the image of the survey station is located at the center of the circle. 3. Extend and retract the legs of tripod so that the circular level bubble is centered. Then, rotate the foot screw to level the instrument using the collimator. 4. Check the centering. If it deviates slightly, loosen the connecting screw and move the instrument to align the circle with the survey station point for accurate centering. If it deviates too far, reposition the tripod until the centering requirements are met. Another important condition to ensure that the geometric relationship of angles does not change is to project angles. Therefore, the instrument needs another adjustment, which is leveling. The purpose of leveling is to ensure that the horizontal circle of instrument is in a horizontal position, or that the vertical axis of instrument is in a plumb direction. Leveling includes 2 steps: rough leveling and fine leveling. First, use the foot screw to make the circular level bubble centered, that is, roughly level. The circular level bubble is centered mainly by adjusting the height of tripod legs or rotating the foot screw. The rule is that the circular level bubble moves towards the side of the extended tripod leg. Then it comes to the fine leveling, that is, static leveling. Fine leveling is achieved by rotating the foot screw, so that the collimator bubble is centered in both directions perpendicular to each other. The method of fine leveling is as shown in the figure below. First, rotate the instrument so that the collimator bubble is parallel to the connecting line of any 2 foot screws. Use both hands to simultaneously rotate these 2 foot screws in the opposite or same direction to center the bubble. Then rotate the instrument 90 degrees so that the collimator is perpendicular to the connecting line of the first 2 foot screws. Rotate the 3rd foot screw to center the bubble. If the collimator is positioned correctly, repeat this step several times to finish fine leveling. That is, the bubble is always centered or deviates no more than 1 mesh wherever the collimator is rotated. After the centering and leveling work, ensure that the instrument is qualified for angle observation. Then observe the target angle. Step 3. Aiming. Accurate aiming at a target requires different crosshair aiming based on the size of target and the observation angle to ensure the accuracy of observed values. Step 4. Reading. Read from large to small values. Read them for a first, second, and last time. Values in degree and minute are very clear and not selective, but values in second require careful comparison and estimation. Till now, this lecture comes to the end. I hope that after this lecture, you can master the 4 steps of placing a theodolite. After class, you may also follow the video instructions to learn the placement and operation of a theodolite, in order to prepare for the precise observation content of the next class.